Hi, so the goal of this video is to think of a way to describe discrepancies between two subgroups along various characteristics, and present this in a way in Excel, present this in Excel in a way that is very easy to read for a non-technical reader. Will show differences between the subgroups and can even detail if those differences are statistically significant, all in a chart form, all that are very intuitive just upon looking at it. So that's the goal. So let me show you what I'm talking about. Okay. So I have data here. My project is looking at urban versus rural differences in physicians. And I have a couple of sets of data. Okay. Here I have different specializations of the physicians. Over here I have different settings that they work in. And I'm presenting basically what's the distribution of rural physicians versus urban physicians. So for example, this bar graph, this bar shows the urban physicians, the percentage of urban physicians in family practice, over 20%. Urban physicians, there's much less. It's near 13%. There's a big gap here. A lot more rural physicians work in family medicine. On the other hand, a greater part of the distribution for urban physicians work in specialized medicine. Okay, so these are two big differences that we might want to think of. And we're here in Indiana, Pennsylvania, kind of a rural environment. You go to the doctor, you need to go to a specialist. They may refer you to somewhere in Pittsburgh. Okay, so that's kind of what this is showing here. Other places, pediatric visits, specialists, and generalists, more likely to be a bigger percentage of doctors, urban doctors, are there. There's much fewer, lower part of the distribution is in rural areas. Internal medicine is a different story. OBGYN, they're about equal. So that's what the type of information we want to know. And all that's presented here by just showing the difference in means of these distributions. So that data is given right here. This is this is the distribution of these rural physicians, and here is the data for the distribution for urban physicians. Okay, so that's part. We want to look at the mean. The other thing, however, is this gap is very wide. So there's no question that there's an urban-rural difference. But what about, say, this gap in internal medicine, or this gap that's much closer for surgery or anesthesiology? Those are a little bit closer. Now, are those gaps real? Is this gap a real urban-rural difference? Is this gap in pediatrics a real rural discrepancy? Or is this anomaly of a sampling phenomenon, really? So we want to know, is this gap really, is it statistically significant? Do the data we're using indicate a real gap here, or is it one that's just driven by the data? So in addition to the means, we also want to know the variation of these doctors. And what I am doing here is I'm putting error bands along with the bars. Okay, and now the thing is, bars that don't overlap are suggestive of a real difference. Okay, so here, the family mean is about 21%. The error bands go up plus or minus 1%. Okay, so that's what that's showing here. 21%. The error band is between 20 and 22. The urban mean and error band is way down here, near 13%. Okay, there's no overlap here. It's clearly a difference. It's a statistical difference as well as a large real one. Okay, so we can look at what are the actual gaps and what are the statistical differences right here. This gap is much smaller, but again, the bands do not overlap. Now it's also suggesting, since they don't overlap, that this is an actual difference. Now, just a bit of the technical aspect of this. These bands are not 95% confidence intervals. I'm using a paper here by Knoll, Pessman, and Groby. Okay, statistical difference, you want to isolate, you want to identify that the difference in these means has a p-value of less than 0.05, or a type 1 error of 0.05. Now that 0.05 doesn't correspond to 95% confidence intervals. Okay, I use the data here to say, based on differences in the standard deviations of my population, okay, the standard deviation for rural is about 0.9, it's about 0.3 here. Well, those standard deviations differ by about 3, so I don't need a 95% confidence interval. I only need an 89%. So I would encourage you to look through this paper and look at the relationship between confidence intervals and means testing. You don't need a 95% confidence interval. It's actually too wide. We only need an 89%. So the confidence intervals for these bars are 89%, which suggests if they're non-overlapping, we are confident that there's a type 1 error probability of 0.05. Okay, so that's what we have here. So to summarize this part, non-overlapping confidence intervals are different. Okay, statistically different, rural-urban differences. Okay, how did I come up with this graph? Well, let's show you. I have rural data here, urban data here. What I want to do is I want to highlight the descriptors and the means here. And I go to my chart page. I like these clustered bar charts. I think they look pretty nice. Okay, so I have this data. It's upside down, family to other med, 20% to about 25%, 21, 25. This is all lined up. Okay, one thing I want to do though is I want to add the urban physicians as well. So I can go to select data, and it brings up the data series. Okay, series 1 was my rule, but I don't want it to say series 1. I want it to actually say rule. So I can click on this value right here. Now you can see, instead of just saying series 1, it says rural physicians. Okay, now I want to add the urban physicians. So that gives me series 2. I'm going to add this name, urban physicians. Oops. Just blank that out, urban physicians. And the Y values I'm going to take is the data here. Okay. Now see, everything's lining up. Other meds are 31%, which is out here for the red. Other med for rural is 24%, which comes right here. So everything's all lined up. The category variables for my urban physicians is, again, this group right here. Okay, so everything's lined up. Now let's fix this in a couple of ways. I put family on top because it's, fairly important. I want that to be reflected here. So let's start manipulating this graph a bit. I'm going to click, I want to manipulate the axis here. So I'm going to format the axis. And I want the categories in reverse order. Well, I mean, I want them in the right order, but for Excel, you have to click reverse order. So now I'm looking at rural and urban physicians, family through other medicine, and that's what shows here. Rural is in blue, urban is in red, family through other specialties are right here. Okay, so this shows the difference in the mean. But again, I want to capture the error bands. And our error bands are, I'm using, for the 89% confidence intervals, I need to take the standard error and multiply it by 1.59. And again, the techniques, or coming up with that number is kind of beyond the scope. But to do it, I just multiply the standard error times this number, and I do that for each group. And so now this is the error band. Okay, 21% plus or minus 1% here. How do I add that here? Well, I'm going to double click on this data set. This is capturing just the blue bars, which is just the rural physicians. Double click that, and I go to error bars. Now I think it has no error bars now. I want to display both, because I want it to look at the high and the low side, and it's easier to read if there's a cap on it. That's just my preference. Now the error amount, I'm going to click on custom and specify a value. Now the plus and the minus side of the error bar is the same. It's this area here. So I'm going to click here and drag down. Okay, and then the negative error bar is going to be the same group of data. Let's see if that works. There it is. Okay, my error bars are about plus or minus 1% here. Let's go look at psych. Okay, I have 2% for psych down here. It's much smaller for psychiatry. All right, so that gave me the error bars for the rural physicians. Let's do that for the urban ones. I need both. I need a cap, and I need a custom value. Okay, those error bars are the range here. These custom bars are the same range. And I click OK and OK. So what's going on here? So the urban physicians, there's a lot more of them in the data. I think roughly 4 or 5 times more urban physicians. So the standard errors are much smaller. The error bars are much smaller for my urban physicians than it is for my rural ones. But again, now we have a visual that shows not only the gap, but whether that gap is statistically significant at 5%. Whether that means it's a way of capturing of indirectly showing a means test here. Okay, this passes a means difference. This does not, because they just overlap. Again, these just overlap. These just avoid overlapping. So there's a means difference for internal medicine. It's all shown in this nice, easy to use graph. If you don't understand the statistics, you can see the clear differences clearly. If you understand the statistics, this is an accurate depiction of a means difference. So to summarize, this nice way of showing these differences between 2 subgroups in a population, a way to accurately depict whether the means are different using error bars. There's some more technique there, more statistics there that needs to be known, but I would recommend looking at this paper that looks at, many people use the 95% confidence interval and think that that indicates that there's a you're doing a means test with that, but it's not directly the same. There's a little bit of a different type of calculation there. So we adjusted that using our error bars. So overlapping and non-overlapping confidence intervals go with the means test here. It's an easy way to present this information, and good luck with it.